Hello everyone, welcome to the discussion of UPSC Mains 2022 GS paper 1 geography portion. Now this year if we see the geography portion, out of the total paper from geography, 8 questions were asked. Now these 8 questions carrying the marks 100 marks from geography. If we see the further subdivision, 4 questions were straightforward asked from physical geography, and these were very straightforward questions, and the remaining 4 were the mix from the remaining part of Indian geography and economic geography as such. So let's discuss these questions which has come. The first question that we come across was question number 4 in the paper, okay, which was describe the characteristics and types of primary rocks, purely from physical geography geomorphology portion. So in this, the answer structure, if we see, the first thing that is in the introduction, you can start with simply the definition of igneous rocks itself. The primary rocks here, they are referring to the igneous rocks formation. And so we will start with the definition of igneous rocks, that they are formed from the cooling and solidification of magma or lava. This would be the introduction paragraph. From here, the next part that we move to is the body part of the answer, where first we would be discussing the characteristics of these rocks. So the characteristics of these rocks, first of all, the characteristics if we see, so these rocks are crystalline in nature, first characteristic. They are non-stratified. Then beyond that, these rocks are or do not contain fossils. So do not contain fossils. Apart from that, now these rocks are non-porous. Then hard and difficult to erode. And lastly, these rocks, so 5 characteristics over here. The 6th characteristic, that these are most abundant rocks, most abundant in the crust. So these are the basic characteristics of these rocks which can be identified. Going beyond this, the next part of the answer, that is the types which have been specifically asked in the question. So under the types now, the igneous rocks or the primary rocks over here, we can identify them as of 2 different types. The one that is intrusive igneous rocks, and the another one that are extrusive igneous rocks. So intrusive and extrusive igneous rocks. Intrusive igneous rocks here, the rocks which are formed within the surface of the earth, and extrusive which are formed on the surface of the earth. So under intrusive, what we will be doing in our answer is we would be giving examples of intrusive igneous rocks, where the different types of intrusive igneous rocks can be identified as batholith, sills, dikes, lapolith, and so on. And probably we could have drawn a diagram also over here, given the shape of these rocks. Say for example, now in this case, the rock, this one, which I can identify as batholith. Similarly, we can have the sill formation, the dikes, and so on. So this type of diagram could have been drawn over here. And then coming to the extrusive igneous rocks which are formed on the surface of the earth, and forming on the surface of the earth, again you could have given certain examples over here. Say for example, pumice, granite. So these are certain examples that we will be putting for the extrusive igneous rocks, and your answer is completed. So you see the question, describe the characteristic and types of primary rocks. This is the first question. Then taking a look at the second question, which was question number 5th in our paper. Okay, it reads, discuss the meaning of color-coded weather warning for cyclone-prone areas given by Indian Meteorological Department. Now, this question, if we see, this primarily comes up under disaster management, but yes, yet came in paper 1. So in this case, what we can do is we can associate it somewhere with the disaster management aspect. And hence, to start the answer and to provide it that particular linkage, what was probably the demand of the question. Okay, in the introduction, we'll start with giving the idea of Yokohama Conference 1994. And this Yokohama Conference 1994, it particularly identified the role of early warning in the mitigation of the impacts of disaster. So we will be writing this particular idea in the introduction itself, and here we are linking it somewhere to disaster management. From here, when we move on to the body part of the answer, okay, straightforward, we would be catering to the demand of the question. And so in the body part, we start with giving the idea of what is this color-coded warning system. And this color-coded warning system, so 4 color-coded warning system is what IMD uses. Okay, the 4 colors which are green, yellow, orange and red. Now, based on these 4 color schemes, what is exactly this warning system? So you see over here, green. When green is there, green means all is well, which means the conditions are good. Okay, there are no adverse favorable weather conditions, and so no action is needed. But when it comes to yellow, yellow starts with the idea that there may be probably, or there is a probability of weather turning bad. There is a probability. Okay, there are high chances. So in that case, be aware, watch and stay updated. Then the next color used is orange, and orange is the warning for extremely bad weather conditions in which electricity blackout may happen, communication disruption may happen, and that's where you have to be prepared for it. And lastly, red color, okay, which is extreme climatic conditions, weather conditions, and bad weather. And there is primarily over here the idea that there is very significant risk of loss of lives. And so the idea straightforward is to take action. So in this case, what can be seen is green, all is well, no action needed. Yellow means as of now the weather is okay, but weather may turn bad, so be aware. Orange is where there is a warning for bad weather, and so you should be prepared for it. But red is where you should have to take some action, because this is where there is a risk to lives. So these are 4 color codes that are used by IMD. And after this, in the conclusion, what we would be writing, you can see over here, the question is saying color coded warning system for cyclone prone areas. But we have to understand that it's not, the color coding warning system is not particularly related to the cyclone, but rather for other extreme weather conditions also. So that is something what we will clarify in the conclusion. That is, warnings are universal in nature and also issued during floods, heat waves, snowstorm, or any other such extreme weather conditions or dangerous weather conditions. This is the second question. After this, moving on to the third question, which was the 6th question in the paper, discuss the natural resource potential of Deccan Trap. Now, this would be economic geography, India. In this case now, first, if we have to start the answer itself, the best way, because we have a term already present in the question, which is the indicative term, Deccan trap. So I may probably start my answer with defining the Deccan trap itself. The Deccan trap is a part surrounded by, let's say, Satpuras in the north and Western Ghats in the west and Eastern Ghats in the east, a triangular portion. So we'll first start with the definition of Deccan trap, and then now asking about natural resources. The question asks about natural resources. So we'll have to think of what all different types of natural resources we can talk about. Here we will have to focus on the categorization, the category of the resources itself. So what can be done in this case is, in the body portion, the resource potential, first thing, the resource potential, under resource potential, what are the resources we are taking is the first, that is soil resource. And in terms of soil resource in Deccan trap, I can primarily talk about two basic types of major categories of soil. Okay, which would become, first of all, we will write about the black soil region. Okay, found in Maharashtra region, northern Karnataka region, and then we will write that it is very good for cotton cultivation. That's one type of soil, and another widespread type of soil over here is a red soil. So these two types of soil we would be writing under soil resource. Next, when I move to, then we talk about mineral resources over here. Again, now mineral resources, which mineral resources we can cover over here? So first, again, we can talk about coal here. So coal is found in Maharashtra, the Vardha Valley region, Telangana region. That's the first mineral resource. Or apart from that, now you can talk about iron ore. We can talk about gold reserves over here. So few mineral resources would have been given here. After that, we'll talk about energy resources over here. And in case of energy resources, what are these energy resources we can think of? So again, if you want to write coal over here, you can write here, or you can put it over here also. Doesn't matter. Apart from that, beyond that, we can talk about, let's say, wind energy. So in terms of wind energy, very clearly, the states, including Karnataka, Tamil Nadu, Andhra Pradesh, as well as Maharashtra, have been identified very clearly as the regions which have a very high potential for wind energy generation, because these are identified as the windy states. So wind energy is one such aspect you can talk about. Then petroleum and natural gas. So petroleum and natural gas potential in this region. Going beyond that, now we can talk about the uranium reserves. Uranium as well as thorium reserves. So thorium, although is found in the coastal areas and all, okay, uranium, very recently, we have found some good reserves of uranium in Karnataka region. So all of this can be put under energy resources. So you have under the resources, soil resource separately, mineral resource separately, and energy resource separately. And last, after this, the next question which was asked was question number 7 of the paper, which read, examine the potential of wind energy in India and explain the reasons for their limited spatial spread. Again, a question from Economic Geography India. So first thing in the introduction, so in the introduction part, what we can write is exactly relate this whole idea of wind energy now probably to, there are different ways of starting the answer. One way is you can start it with the aspect related to climate change issue. and therefore the need to develop more of renewable energy resources. So that will start with the idea of significance of wind energy. So first in the introduction, we can start the answer with significance of wind energy. After that, in the body part, we would be starting or directly catering to the demand, where it is first part is asking potential of wind energy generation. So that's the first portion of my body part of the answer. And in that, I'll start with the installed capacity, how much is the installed capacity and all. So you can see the facts over here that India has a fourth highest wind installed capacity in the world, where our installed capacity is 39.25 gigawatts. That's to start with. And then I'll directly jump to the potential part. Now, potential for wind energy generation, what we can see is wind energy generation requires some substantial speed of the wind. And that's where it's limited to few windy regions or windy states of India. So with this respect, if you see under the potential, first thing, total potential we are telling, which is a data which everyone is supposed to remember. So somewhere around roughly, even if you say 300 gigawatts or so, but 302 gigawatts at 100 meters height and 695 gigawatts at 120 meters height. That's the first thing about the overall total potential of wind energy generation in India. But apart from that, the aspect that I was saying, that the potential is limited to few windy states. So more than 95% is found in the 7 windy states only. Gujarat has the highest potential. The other states, if you see other 6 states, becomes Karnataka, Andhra Pradesh, Tamil Nadu, Rajasthan, Madhya Pradesh, Maharashtra. So these are the 7 regions or 7 states where majority of the wind energy generation potential remains. So this is the potential part. That is the first part of the question. Second part of the question asks me, explain the reasons for their limited spatial spread. And the answer somewhere lies here itself, part of the answer, where why it is concentrated in only 7 windy states. But probably I have told you this idea that it requires substantial wind speed. And that's one of the reasons why there is limited spatial spread in the potential. So when I think of the reasons for limited spatial spread, the reason first of all is every region in India is not windy enough. It does not have substantial speed of the wind. Okay, going beyond that, the topography challenges. Topography challenges here primarily means that first thing, to construct a wind energy farm, you need a very large area. You need plain areas and all, okay, which definitely provides the, comes in the form of topography challenges. In addition to that, in some areas, the topography provides some favorable conditions also. Like say, for example, if there are some passes in the mountains, wherever, let's say, for example, Pal Ghat Gap in Western Ghats. So it tunnels the air and so increases the speed of the wind over there. So somewhere certain the topography and all may be favorable, but it comes in the form of challenge also. Going beyond this, the same idea, that is, it requires a very large area, the wind energy farm, and so land acquisition always remains a challenge with respect to this. Then beyond that, a lot of wind energy power potential is found in the remote areas. Remote areas we say because in other areas there are a lot of obstructions and all that may be there in the form of artificial structures which may be present. So in that case, majority of the potential is in remote areas, but yet the problem is if you generate electricity over there, okay, then you should have proper grid connection over there for the supply of that generated electricity. And so grid connection challenge is a direct challenge with respect to the remote area potentials. So these are the potential reasons, the second part of the question, the reasons for their limited spatial spread. Now, let's move on to the next question of the paper. And so these were, so up to here, up to this question, okay, these were all 10 markers that we got. After this, the 15 markers began, and the question was 14th question in our paper. What are the forces that influence ocean current? Describe their role in fishing industry of the world. Now, this is a direct question from physical geography, oceanography. No complication in the question or in the language of the question itself. So first, if you think of the answer in the introduction part, in these type of questions, it's a very good idea to start with the definition itself. And so over here, we'll in introduction paragraph, we will write the definition of ocean currents. Okay, that ocean currents are the movement of large mass of water, ocean waters, in a particular direction. After this, let's deal with the two different parts of the question. The first asks me, what are the forces that influence ocean currents? So now talking about the forces over here, what are the forces or what are the factors which generate these forces? So first thing that we see is temperature gradient. Temperature gradient, where the ocean waters always tend to move from high temperature areas to low temperature areas, and is pretty much evident from the movement of ocean currents itself, where the warm equatorial currents, okay, tend to move towards the poles. So temperature gradient is first. Similarly, second, that is salinity gradient. And in salinity gradient, again, the idea is the ocean waters tend to move from the regions of low salinity towards high salinity. Then we have rainfall difference. So very obviously, the regions where rainfall is high, the overall volume of water, or what we can call as the net sea level in that particular region, would be more compared to the area of low rainfall. And so over here, the waters will tend to move from high rainfall region to low rainfall region. Temperature, I told you, temperature is where the tendency is to move from high temperature to low temperature regions, or warm water to cold water. So these themselves create these gradient forces. That's why we have written it a gradient. So that's the aspect. Apart from that, wind is a very, very prominent and dominant force influencing the ocean current. And in here, when writing the wind, one good idea would be to give some examples also. So when the winds are blowing, they are dragging the ocean waters with them, influencing the direction of ocean currents. And a very good example of this can be given as west wind drift. So west wind drift are purely driven by westerlies, okay, in the southern hemisphere. And then comes up Coriolis force. So where Coriolis force impacts the direction of the movement of ocean currents, but thereby deflecting them towards right in the northern hemisphere and towards left in the southern hemisphere. And to introduce some technicality to this particular explanation, okay, you can mention over here the Farrell's law. Farrell's law, which tells us the direction of deflection, that is right in the northern hemisphere, left in the southern hemisphere. So that is the first part of the answer, forces which influence the ocean currents. Now, the second part of the question, describe their role in fishing industry in the world, how ocean currents influence fishing or fisheries. So the role in fishing industry of the world, the first factor comes up over here is meeting of warm and cold ocean currents. Now, meeting of warm and cold ocean currents, wherever the warm and cold ocean currents are meeting, it produces the temperature, okay, in the range of 20 degrees Celsius to 30 degrees Celsius. And this is the temperature range, which is the most optimum or favorable temperature range for the growth of fishes. So all the areas where warm and cold ocean currents are going to meet, okay, these are the areas which will have very rich fish resources. And while explaining this, definitely you will have to provide examples. So example over here, what are the examples I can provide? So one example I can provide would be that of Grand Bank. Grand Bank, Newfoundland region. And Grand Bank is where, which ocean currents are meeting? So this is where Gulf Stream meets Labrador current. Similarly, one more example here you can provide, that is the region off the eastern coast of Japan. So off the eastern coast of Japan. And this is where Kuroshio and Oyashio, the warm Kuroshio and the cold Oyashio currents meet. So both of these regions are very rich fishing grounds. Secondly, apart from that, another role that can be seen in the areas of upwelling. So whichever are the upwelling zones, in the upwelling zones, what happens in the upwelling zones? The cold waters which are coming from the bottom, now they bring nutrients from the deep ocean to the surface. On these nutrients, phytoplanktons grow. And when phytoplanktons are there, they will become primary food for the fishes. And so there is a good number of fishes that can be found in these regions. And good examples over here can be given as California region, very importantly, Peruvian coast, so in California region, we know, yes, cold California current flows. Similarly, along Peruvian coast, Peru current or Humboldt current is there, and both the regions are the regions of active upwelling. So that's where the two roles of ocean currents in fisheries is how you will, this is how you will explain it. But most importantly, examples. Everything has to be substantiated with the proper examples. So this was question number 14th, 250 words, 15 marker. Let's move on to the next question. The next question was question number 15th. Describe the distribution of rubber producing countries. Indicate the major environmental issues faced by them. World Economic Geography. Okay, along with that, the environmental aspect. So in this case, the first thing over here for this answer, the introduction part, if we see, we'll just write about rubber, the growth of rubber, in which we can tell that rubber is a tropical tree, and very obviously rubber requires high temperatures almost throughout the year. Okay, not seasonal high temperatures throughout the year. Anywhere when the temperature goes below 20 degrees Celsius, that proves to be detrimental to the rubber tree, and so requires high temperature throughout the year, and along with that high rainfall. These are the conditions required for the growth of rubber tree. So from these conditions, if you think of the regions where, or the countries where rubber is grown, or rubber in the production takes place, majority of them are concentrated in the tropical region, of course, and along with high rainfall. If I see, so Southeast Asia is most important country over here. But if you see overall, Asia produces more than 90% of the rubber of the world. Going beyond that, Africa, exact percentage is 94% for Asia and 6% for Africa. So that's the continent-wise distribution, first of all. Within Asia, if itself, if you see Thailand, Indonesia, Malaysia, Vietnam, okay, these four are from the Southeast Asia region, and along with that, India comes up over here, and that was one of the reasons why this question was asked also, that India is a one country from South Asia, which is in the list of top 5 rubber producing countries. Okay, so India is the 4th largest rubber producing country in the world. Yes, the fact over here. So this is how we'll show the distribution. Along with that, now the second part, that is environmental issues faced by or associated with rubber production. So rubber production is highly detrimental to environment, first thing. Okay, and so if we see over here the environmental issues, the first thing, rubber plantation is done over, okay, large plain areas. And in these regions, the plain areas would not be readily available. We are talking about the regions where high rainfall also is required. High temperature anyways is the tropical region. So if there is high temperature and high rainfall, definitely these regions would be forested regions. And so if you have to undertake rubber plantation, okay, you will need a very large area for which you have to clear the forest. So that's the first negative impact on the environment itself, that is deforestation taking place. And when in these forest areas with high rainfall, the deforestation happens, that straightforward results in a lot of soil erosion. So first the deforestation aspect, and second one, so over here, this one is a deforestation and leading to soil erosion. Then in addition to that, different types of pollutions with which rubber production is associated with, in which there is the aspect of air pollution, there is the aspect of water pollution, and there is the aspect of noise pollution. The air pollution part, if we see over here, the air pollution, that is the gases released, carbon monoxide, sulfates, nitrogen oxides, lead. Okay, these are different gases which are released from rubber production. So first aspect, that is air pollution. Then we have the problem with water pollution. So water pollution, in which the effluent discharge from the rubber production, okay, comprises of very harmful serums. Okay, oil contamination remains in that. Plus, along with that, the rubber production process is associated with very high levels of noise pollution. So we have 3 aspects related to pollution, one related to deforestation, and the resultant soil erosion. Straightforward environmental impacts. So this is the 15th question. Now, question number 16th of the paper. Mention the significance of straits and isthmus in international trade. Straightforward, again, a question from physical geography, oceanography. So first, to write the answer in the introduction part, if we see, the first one way of introducing the answer would be straightforward, again, to write the definition. And here I would mention the definition of strait and isthmus, wherein a strait is a narrow water body connecting two larger water bodies. Isthmus is a narrow strip of land connecting two larger land masses. After this, directly moving on to what has been asked, that is the significance of straits and isthmus. International trade here we are talking about. So first we will take up the straits, and one way of presenting this is to take up the examples of different straits, give the list of important straits, and tell their significance one by one. So if we see over here, let's say the Strait of Gibraltar. So Strait of Gibraltar now provides a connectivity between the Atlantic Ocean on one side and Mediterranean Sea on the other side. So Strait of Gibraltar becomes very important for West European countries to get access to the Mediterranean Sea, as well as from there further on getting access to Indian Ocean, that is Arabian Sea. Next comes up, that is the Strait of Bosphorus. The Strait of Bosphorus connects Black Sea with the Mediterranean Sea. And this is a very, very important trade route, the Strait of Bosphorus. So if we see major oil supply from Russia towards Africa and this direction takes place through Strait of Bosphorus. Apart from that, food grain supply both from Russia and Ukraine takes place through this route. Next one, that is Suez Canal. Suez Canal now is a artificial strait, man-made canal, and Suez Canal connects Mediterranean Sea with Red Sea. Now Suez Canal becomes extremely important international route, because if we think of a Suez Canal now, with the opening of Suez Canal, if you see in the earlier times, let's say from London, if a ship has to reach Bombay, okay, it will have to travel all through the Atlantic Ocean, okay, reaching up to the Cape of Good Hope or Cape of Agulhas, and from there entering the Arabian Sea. Now, when Suez Canal was constructed, after this, the straightforward route becomes from London, let's say, you move into Mediterranean Sea via Strait of Gibraltar. Then from Mediterranean Sea, you move into Red Sea via Suez Canal, and further from Red Sea, you can move into Arabian Sea. And with the opening up of Suez Canal, the maritime distance between Europe and Arabian Sea, Europe to be specific, between London and Arabian Sea, has been reduced by almost 8,900 kilometers, a significant reduction. So extremely important canal. After that, next comes Bering Strait. Bering Strait would be the connectivity between Arctic Ocean and the Pacific Ocean. Now, Arctic Ocean, for most of the time of the year, is covered with ice. But for 2 to 3 months, there would be melting of ice, and so the sea route opens over there in Atlantic Ocean. Further, in the present time with the global warming, the maximum impact can be seen in Arctic Ocean only, where there is a lot of melting of ice, which further opens up the potential of this region to be used as a sea route. And so Russia has identified something called as Northern Sea Route, okay, which it can use via Arctic Ocean. And so from that perspective, Bering Strait becomes very important. Likewise, Strait of Hormuz. Strait of Hormuz connects Persian Gulf with Indian Ocean or Arabian Sea. Now, Persian Gulf. So from here, extremely important a strait from economic significance, strategic significance, as we can see that almost 1/3 of the world's liquefied natural gas. So 1/3 of world's LNG maritime trade takes place through here. Similarly, 25% of world's oil trade takes place through this strait. Next one comes up, Malacca Strait. So Malacca Strait provides a connectivity between Indian Ocean and Pacific Ocean, and is a very, very busy trade route. Now, the significance we can just understand from some facts, like say, for example, 40% of global maritime oil trade takes place through here. Similarly, China is heavily dependent on this strait, Malacca Strait, and almost 80% of China's petroleum import takes place through Malacca Strait. So these are different straits and their economic significance or significance in the international trade. Next, we move on to isthmus. And isthmus is a strip of land connecting two larger land masses, or you can say separating two water bodies. So if this is a land mass X, this is a land mass Y, and if this is the isthmus, this is the narrow strip of land. On the two sides, I have these water bodies. So definitely, isthmus actually provides an obstruction to this maritime route between from one water body to another water body. But if a canal can be constructed across the isthmus, okay, it will provide a very significant passage from one ocean to another ocean, or from one water body to another water body. So we will take up in our answer the examples of two very important isthmus. The first one, which is Panama Isthmus. Panama Isthmus connects North America with South America, which means it separates Gulf of Mexico on one side and the Pacific Ocean on another side. So likewise, they have constructed Panama Canal across it, cut across the Panama Isthmus, and Panama Canal now provides a very good connectivity between, let's say, eastern seaboard of USA and the western coast of USA. Likewise, we have Kra Isthmus. Kra Isthmus now connecting Thailand with Malaysia. And from very long time, there have been suggestions and discussions to construct a canal also similar to Panama Canal. But very recently, good news is Thailand, the government of Thailand has agreed to set up a committee to study Kra Canal project. This is very recent news. And if you write this in the answer, definitely it gives that touch of current affairs linkage also to otherwise a static question. So this is the content part. And along with that, given the nature of the question, definitely it gives me a major scope of using map. So we'll include over here a world map where what we can show, you can see in this map, we have shown the important straits that already we have discussed, mentioning their locations, all these list of straits and showing in the map. Apart from that, what we have done is, one, we have shown this one as northern sea route, what Russia has identified through Arctic Ocean. And we can see if we extend this northern sea route, okay, reaching right there up to Bering Strait, that again can be another connectivity. Then another aspect of sea route, which I've shown in the map, is the older route prior to opening up of Suez Canal, which was through Cape of Good Hope. Now with the opening of Suez Canal, this is the new route. Strait of Gibraltar, Suez Canal, Strait of Bab el-Mandeb, and the access to Bombay. So this is our discussion of question number 16th. The next question, which was the last question, question number 17th. Troposphere is a very significant atmosphere layer that determines weather processes. How? Again, a 15 marker, and can see straightforward a direct static question from physical geography, climatology. So to deal with this particular question, first thing in the introduction, we would be writing some information about troposphere. Let's say, for example, troposphere is the lowest layer of atmosphere, which is also known as weather layer. Now, this mention I have made because this is exactly what the question is asking. When we move on to the main part of the answer, we have been asked the significance of this layer. And the significance, first thing what we see is in the troposphere, the lapse of temperature is a negative. There is negative lapse of temperature, what we call as normal lapse rate or environmental lapse rate. Due to this negative lapse, that is the temperature decreasing with height, the feature that I get in troposphere is convection currents. And these convection currents are vertical movements of air. Now, due to these vertical movement of air, we get a lot of different weather phenomena or weather processes. The first one you can see is convection current results in formation of cloud. So we'll be explaining this process, convection current, how it results in formation of cloud, and that causes precipitation. And in any region, the weather is determined by the temperature, by the precipitation. So over here, the first significance. Second significance, it is the troposphere only, which holds all the water vapor of the air. And water vapor in the air, so with respect to that, again, you can write in this part, the first aspect, that is the formation of the cloud or precipitation and other weather processes. Along with that, water vapor is a very important greenhouse gas or greenhouse component. And so we'll write in a positive way itself, that is, it is responsible for greenhouse effect, where the greenhouse effect is very important for maintaining optimum temperature on the earth, warming the earth, not extraordinary warming that we are calling as global warming, but generally keeping the earth warm. Along with that, you can see different processes of heat transfer. The heat transfer, when we say how the heat transfer takes place through across the earth, or between heat surplus regions and heat deficit regions, providing a heat balance to the earth, that takes place through the phenomena like winds. Cyclones play a very important role. And all these phenomena are taking place right there in the troposphere itself. So we have convection current role of water vapor, role in the heat transfer. These are the important significances of the layer that is troposphere. Yes, it was 15 marker to 50 words. So we will need to explain these points, how these effects take place. And so this becomes the significance of troposphere in determining different weather processes. So this is the discussion on the 8 questions that came in the mains examination 2022 GS paper 1 geography portion. Thank you very much.